Hello, so this is going to be the final video on clustering I'm going to do. I'm not aiming to try and do very specific weighted k-means clustering techniques or go into detail of the individual algorithms that are out there. But what I wanted to try and bring together is this idea that clustering techniques are not necessarily about maths, and they do have a specific place in terms of the investigation and looking into data, trying to form clusters and groups and trying to figure out what forms those clusters and groups. So as you can see here, we've got some credit card information that's come from Kaggle. I've split it up so it's the credit limit and payments information, and I've already finished and I've got 5 clusters. But that's not necessarily helpful, because actually what you want to do is an initial investigation of this data. You want to work out where there are major splits in the data. So what I'm going to do is try and show you an exploratory technique that you might follow and the way of organizing your thoughts about it. So we've got our Kaggle data, which is the credit card data set for clustering, and if you want to download and follow along, that'd be great. With k-means, you have to make sure that these two values are roughly similar, and a good rule of thumb is if you're having problems, resize them both so they're both in the same range. So you might resize that down to 1 to 10 and that to 1 to 10 if you were having problems. I haven't had any particular issues with this in this stage. You do want to exclude all the NAs, which we'll do with the NA omit command. You then want to just include the 2 values that you want to test. As you can see, I've gone and taken it out of one data frame and put it into another. I'm then going to create a 1 to 15 list, which you can see here. And we're going to do something a bit weird. What we're going to do is we're going to write a command that says for k in 1 to 15, which means it's going to run 15 times. And then for each of those times, it's going to add in a value into WSS, which is the sum of the k-means, and with an increase of the amount of centroids that it's producing each time. So what this is going to do is it's going to do a test of what does each centroid include in it. If I have 1 centroid, then if I have 2 centroids, and when I show you the graph in a second, it will make sense. Just why it runs. So if we plot the data, you can see that we started off looking at just using 1 centroid, then 2, then 3, then 4. This is in the end I used 5, but you can sort of see this sort of shape of this curve, that if it's really steep, that I've seen a number where it just drops straight down to 3, and you know that there is 3 clusters really there. So each of those clusters, it's worth thinking about if they're related to a different variable, if they're collinear. I'm pretty sure that's the wrong word, but because it's got to do with linear regressions, but we'll use it for now. Covariant, I think, is the right word. If they're covariant, as in the cluster number 2 is always to do with people who are over 30, you can then start to look into it. So what we'll do is we'll do our normal. And I'm going to go down because I haven't seen it with 4 clusters this time. Because I do find it slightly interesting, because it does. If you look at the graph, 4 is pretty stable, and I'm not sure whether 5 is where it's actually rolling out. And you run through the normal k-means process of creating those clusters, adding them into the original frame, so you've got the data to plot, and creating a plot for 4 clusters. And as you could see in the first one, there was a big group here, small group here, then there was one there, and then there was these ones. That's not what you've got this time. You've got this highly concentrated group. And what I want to challenge you on is doing data analytics and data science is exploratory. What I would suggest is, having done this clustering on just 2 variables, you would have now a very good idea that this is definitely a very concentrated group around this value of credit users, and then you've got these other groups over here. I'd look for a variable, and you can do that now by adding back in the other variables into this, or moving the cluster onto your main data set and looking for obvious splits in the data which might give an explanation. If all these one data is related to that, that's a great way to explain. And what you can do is move along from different pairs of variables and generate a hypothesis. Obviously, you're not going to do it with variables that you just think there's no way these two are going to be linked, but you might be interested. And this is where I sort of challenge you on. You've now got this idea with this k-means clustering methodology of taking a data set and just based on the numbers splitting up that data into groups. Now, what if this was petal size and stem size, and these were different flower genetics, different flower and plant species? You could go and start questioning whether each of these was a distinct species. I mean, that's probably not species, that's probably just outliers, but you can kind of start to see where there's a sort of a methodology in this, because unlike doing it with locations where you're thinking about in terms of maps and groups of towns, you're actually looking for a sort of type of phase space, because there's no real reason why these two variables should mix together like this. But if they do, and you're finding distinct clusters in your data, there's probably something going on. And this is a good way of sort of having built some graphs, having then done some hypothesis tests to see what variables you think are involved, having then created some clusters to say we've got these groups of people or things or items that all seem to show relationships. Then the next question is, what are the relationships, to then move on the investigation. And hopefully you can sort of see this is a bit more like playing Sherlock Holmes than what you did in Excel, where you just created a graph and you reported on it. So I hope that's interesting. Good night, good day to you. I hope you have a good one.